Yo, Chuck.
Hello YouTube. So today we're going over Radix Sort. Radix Sort is an integer sorting algorithm. When I say integer sorting, that means we're sorting based off of digit amounts. So for instance, a number like 1 has one digit. We know that a number like 10 will always be greater than 1 because 10 has two digits. And we know a number like 577 will always be greater than 10 because 577 has three digits. So what we do in Radix Sort is we take each number and we analyze its very first digit. So for instance, 3221, the very first digit would be 1. So I'm going to place this number in a bucket with all numbers whose first digit is 1. So like 1 would be a part of that. Okay? And basically I'm going to make 10 buckets, 0 through 9, to accomplish this. And I'm going to place all these numbers in their respective bucket. Once I've done that one iteration, I'm going to unpackage them. And then we're going to do the process again, this time analyzing the second digit, and then I'm going to place it in a bucket. So it's a lot easier to understand if you can visually see it. So I'm on this website called Visual Algo, and this is an excellent website to visualize algorithms. But here I'm going to play just so you can see what I mean with these buckets, okay? Okay, so I'm stopping right there. Notice we're analyzing the very first digit and placing it in its respective bucket. Okay? We've done that with every number. Now I'm going to unpackage every number that I've placed in a bucket from the bottom up. And you'll see what I mean here, but we're going to now move to the next digit when we analyze again. But first, we're going to unpackage. So watch the unpackaging. So notice after each iteration of unpackaging, our numbers or our array is one step closer to being organized. Now let's analyze the second digit of each number and place it in its respective bucket. Okay, so it's important to note some numbers don't have a second digit, like 1 or 7. They are considered a zero amount, so we put them in the zero bucket. Now we're going to unpackage again, and it's time to analyze the third digit. How many times do you think this iteration is going to happen? It's going to happen the amount of max digits there are in your largest number, which would be 4 iterations. So that was our third digit where we put buckets in according to that third digit. Now we're doing another unpackage, and then we're going to analyze the fourth digit, which is the last digit, the last iteration we have until we are completely sorted with this array of numbers. Okay, we've placed all of our numbers according to that fourth digit. Notice how if the digits can't be satisfied, they're placed in the zero bucket again. Now, one final unpackage, and all this data will be sorted. Okay, so there you have it. Now, it was important to show you this because it will make a lot more sense when I show you the code. So stay tuned for the next part. All right, guys, now that you've seen the visual representation of Radix Sort, this code will be a little more straightforward. So first, before I can even get started though, I need to make these helper functions. I've made videos on how to create most of these, but I'll just run through it real fast. They're not even too bad. So I'll start with the count digit function. This is just going to take a number and then count how many digits are in that number. So let's just return the number to make sure everything's working. Okay, so I'm just going to say math.log base 10 number. So what to the power 10 to the power of what equals number? And that's like what, like 2 point something? I'm just going to floor this. And it's going to equal 2, so I just need to add 1. And now this should work. And this will always give me the correct digit amount. There is a edge case you need to account for. If someone puts in 0, it could totally screw everything up. So you need to say if num equals 0, return 1, and that fixes it. And then also, if somebody puts in a negative number, that'll screw it up. So you need to take the number here and then say math.absolute number, and that'll fix it. Okay, so that function is done. That's pretty easy. Now I'm going to do the getDigit function. That is going to take a number and an indices of the number as its arguments. So let's call getDigit 1, 2, 3, 1. So basically, index 1 of this number is going to be the 2. And if I was to say index 0, that should be the 3. So that's a little confusing, but it'll make sense. Let's return the number here. Okay, so I'm just going to take number divided by math.pow. I'm going to say 10 raised to whatever I is, the indices. So in this case, I is going to be 1. So it's going to be 123 divided by 10. What does that equal? 12.3. So we need to floor that actually to get rid of that 0.3. That equals 12. And now here's kind of the secret to this one, modulo 10. And now wherever you specify the indices, it'll give you the correct number or digit. And if you go, say I type in a indices greater than anything on my number, like 3, this will just return 0. Or 4 will return 0. Or if I type in -1, it'll return 0. So that function is done. Now on to the most digits. This is really easy. It's just going to take an array. And what I want to return with this function is the most. So you look at all the numbers, and then the number with the most amount of digits, I want to return those digits. So if it's like 1,000, the most would be 4. So let's call this function. I'll pass in some numbers here. I'll say let max equal -infinity. I'll call a for of loop. So I'm going to say max is equal to math.max, the max, and then count digit, and then I'll pass in the element of the array. So what that's saying is we're going to loop through each one of these items in the array, and I'm going to compare the value of max to the count digit value of this current element. Then I'm going to return max, and this should return 5 because 5 is the greatest amount of digits in this array of numbers. It does. Okay, cool, that works. So those are your helper functions for Radix Sort. They're pretty easy to make, honestly. You can do those pretty fast. The math stuff, it's kind of weird at first, but like you pick it up pretty quick. For me, it was more of like a memorization thing, and then it kind of just like makes more sense. Like, oh yeah, of course, log base 10 will help you find how many digits are in a number. Of course it will. Yeah, it's really intuitive, right? Okay, so we've got these helper functions out of the way. Now let's make our Radix sort. So I'm just going to bring this down a little bit. So I'm going to say const Radix sort equals, and it's going to take an array of nums. I'll just say nums actually. Okay, so the first thing we want to do in here is get the numbers. I'm just going to put numbers in actually. An array of numbers. I'll just make it really easy to understand by using numbers like this. Okay, so I want these not in order actually. That would be nice. There we go. So now let's return those numbers, make sure it's firing. Cool. Okay. So we just need the highest digit count. So I'm going to say let max digit count equal, and then what do we call that function? Count digit. So count digit, and then I'm going to pass in nums, or most digits, sorry. Most digits, because we're analyzing the array, right, of numbers. And this will return the max amount of digits. So we'll say return max digit count, and that's 5. Why am I finding this number? Because this is the amount of iterations our for loop is going to do. So I'll come in here, I'll make a for loop, and compare it to max digit count, and then increment it from there. Now, inside the for loop, this is where you want to create your buckets, as you saw in the visual illustration on Visual Algo. So let digit buckets equal, and then I'm going to use the array.from method here. I'm going to pass in a length of 10. Notice the object syntax. Then on each element in this array, I'm going to pass in a function that creates an empty array. So pretty much I have an array of 10, and each of those elements of that array of 10 is its own array. And let me show you what that looks like. Just a whole bunch of empty array buckets ready to be used, and those are 10 of them in total, 0 through 9, just like in the visual representation. Okay, let's get rid of this. Now I'm going to loop through the data a second time, but I'm going to loop over nums.length, so the actual numbers down here .length, and then increment j. Inside this for loop, I need to specify the digit bucket. So I'm going to say let digit equal, and then I'm going to use one of my helper functions here, and that's the get digit helper function. So I'm going to say get digit. I'm going to pass in nums at j, and then pass in I. So I'm looking, remember how the get digit works? You're looking at a number, and then you want to return the indices of that number. So the number I'm looking at is nums j, which is this, 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 and then this. And then the index is related to this max digit count, which we've established the highest would be 5, okay? So that's kind of tricky, but you can kind of wrap your head around it because you can see what nums j is. From here, I'm going to go into my buckets, each iteration of the j for loop, and I'm going to push in a value at digit. Because remember, digit is just the current digit being analyzed. So the first digit would be like the 1 of this 11, the 4 of this 4,444, the 2 of this 22, for instance, okay? So I'm accessing that right here, and now I'm going to push in the value of nums at j. All right? And then I'm going to exit out of this inner for loop, and then I'm going to say nums equals, I'll use the brackets to make an empty array, and I'm going to say concat, and then I'm going to use the spread operator of digit buckets here. And then I'm going to return nums. So remember on the visual representation how we unpackaged those numbers after we ordered them by their respective digit every time? This is what this code is doing right here. It's just making nums be repackaged each time. And each iteration, as you recall, the array of numbers gets one step closer to being organized. So let's see if that worked. And it did. Excellent. It's completely organized. Let's pass in another number like 6. and it's still working. Let's pass in 7. And it's still working. Excellent. So that is how you do radix sort. I feel like the logic is a lot less, it's not as complicated as like quicksort or merge sort even. I think it's more intuitive, just the logic behind pushing, and then you just got to make those helper functions really, and it's pretty easy. So I hope you enjoyed this video. Stay tuned for the next one.